we want to evaluate the integral, and we're going to use integration by parts. So the integral is e to the negative theta times the cosine of 2 theta d theta. So what we're going to do is we're going to let u equal e to the negative theta, and dv is going to equal the cosine of 2 theta d theta. So when we take the derivative with respect to theta, du is going to equal negative e to the negative theta d theta. And then we need to take the antiderivative of the cosine of 2 theta d theta. So if we want to take the antiderivative of the cosine of 2 theta d theta, okay, if we let u equal 2 theta, du is equal to 2 d theta, and then divide both sides by 2, then we would have the following. The cosine of u times 1/2 du. Factor out the constant, and we want to integrate the cosine of u du. So when we take the derivative of the cosine of u, we get the sine of u plus c. So that would be 1/2 times the sine of 2 theta plus c, and we're going to substitute that in for v. So that's 1/2 the sine of 2 theta. Okay, so let's go ahead and write our original question. So we have e to the negative theta cosine of 2 theta d theta, and that's going to equal u times v minus the integral of v du. Well, we know that u is e to the negative theta. We know that v is 1/2 times the sine of 2 theta minus v, which is 1/2 the sine of 2 theta times du, which is negative e to the negative theta d theta. Now let's go ahead and simplify this a little further. So we have 1/2 e to the negative theta times the sine of 2 theta. We're going to factor out the constant, so we have a negative times a 1/2 times a minus. So that's going to give us plus 1/2 times the integral of e to the negative theta times the sine of 2 theta d theta. So what we're going to have to do is another integration by parts. So we're going to have to use this for our integration by parts. So let's go ahead and do that. So we have the integral of e to the negative theta times the sine of 2 theta d theta. So we would let capital U equal e to the negative theta, and d capital V is going to equal the sine of 2 theta d theta. So if we take the derivative of both sides, we get du capital U, which is negative e to the negative e to the negative theta d theta. And now we have to integrate the sine of 2 theta d theta. And remember that we let u equal 2 theta, and du is equal to 2 d theta, which 1/2 du is equal to d theta. So this is equal to the sine of u times 1/2 du. Factor out the 1/2, and then let's take the antiderivative of the sine of u. So the antiderivative of the sine of u is going to give us 1/2 times negative cosine of u plus c, which becomes negative 1/2 times the cosine of 2 theta plus c. So therefore over here this becomes negative 1/2 times the cosine of 2 theta. Now in step number 3, we're going to go ahead and put in the new integration by parts formula. So we have capital U times capital V minus capital V du. And so we have e to the negative theta times negative 1/2 cosine of 2 theta minus negative 1/2 cosine of 2 theta times du, which is negative e to the negative theta d theta. So let's go ahead and simplify this a little further. So we get negative 1/2 e to the negative theta times the cosine of 2 theta. Factor out the constant. We have a negative times a negative is a positive, but that stays a negative, so that's minus 1/2 times the cosine of 2 theta, or in this case here, we have e to the negative theta cosine 2 theta d theta. So we're going to put this and substitute it down here. So let's go ahead and do that. So we have 1/2 e to the negative theta times the sine of 2 theta plus 1/2 times negative 1/2 e to the negative theta times the cosine of 2 theta minus 1/2 times the integral of e to the negative theta times the cosine of 2 theta d theta. Okay, so now we're going to distribute. So let's go ahead and distribute here this 1/2 to those two terms. So we get 1/2 e to the negative theta times the sine of 2 theta. Distribute the 1/2, and we get minus 1/4 e to the negative theta times the cosine of 2 theta. And 1/2 times negative 1/2 is going to give us negative 1/4 times the integral of e to the negative theta times the cosine of 2 theta d theta. So now, because we did the integration by parts for the first time, then we have plus c1. Okay, now if we continue, because we cannot simplify every time we take the antiderivative of this, we're going to end up getting an integral that we cannot simplify any further. So we have to use the left side of this equation. So I'm going to bring this down, okay, and then what I have is the integral of e to the negative theta times the cosine of 2 theta d theta. Okay, now if you notice, we have that here. It's the same thing over here. They're like terms. And you can see that we have a constant in front of that, which is negative 1/4. So what we're going to have to do is we're going to add that to this side. So we have a 1 in front of this integral here. And since we're going to be adding a fraction to it, we're going to say that 1 represents 4 over 4. And now what we're going to do is we're going to add this 1/4 to both sides of the equation. So what happens? We can see that that goes away, and then when we add, we get 4 over 4 plus 1 over 4, which is 5/4, times the integral of e to the negative theta cosine 2 theta d theta. And that's going to equal 1/2 e to the negative theta times the sine of 2 theta minus 1/4 times e to the negative theta times the cosine of 2 theta plus 0 plus c1. So now what we want to do is, since we want to solve for this integral, we're going to multiply both sides by the reciprocal of 5/4. So we're going to multiply this side by 4/5. And then we're going to multiply this side by 4/5. So now we end up getting the integral e to the negative theta times the cosine of 2 theta d theta. And then we're going to multiply each term by 4/5. So we get 4 over 5 times 2, which is 10 e to the negative theta sine of 2 theta minus 4 over 20 e to the negative theta cosine of 2 theta plus 4/5 c1. Now let's go ahead and simplify. So we end up getting 2/5 e to the negative theta times the sine of 2 theta minus 1/5 e to the negative theta cosine of 2 theta plus, well, we're going to let c now equal 4/5 c1, so that's going to be plus c, and therefore that is our result.